now start with the civil features. So civil, it's in this training, it's divided up in two parts. So first I will talk about Earthworks, and then secondly, I will show you a little bit of the alignments and corridor modeling. So let's start with Earthworks now. In BricsCAD, topographical surfaces are created using thin surfaces. So for here, I will show you a lot on how to edit these thin surfaces. So thin surface as in triangulated irregular network. In the modeling workspace, you will have a dedicated tab for civil. So you will find all the commands you need right here. All right, so let's create a thin surface. There are several ways that you can import data to this. You can do it with the CSV file, you can do it with the text file, a land XML, as well as a Civil 3D too. Let's do that. So here I have a lot of text files ready to import, but I actually only want to import this thin surface inside this polyline. So I can beforehand already clip this polyline. So it will only create a thin surface inside that boundary. That way your load for the thin surface will be much faster. So import. So here I have some text files ready. So these are just files with coordinates that I want to have for this thin surface. You can choose for one, but you can also choose for several at once. So if you have a very big thin surface, you can load it at once as well. So if I open that and let it load for a while, you will see that I created this thin surface inside this specific boundary area that I told them to. So otherwise it will be a very big thin surface around it as well. All right, second thing that I want to do is assign an image to this thin surface so it will look more realistic. So here I already attached an image to this. So if I assign image to thin, like this, it will be projected onto the thin surface as well. So like this, I can delete my image and I can just use this one, which already looks much more realistic than before. All right. So now let's start with some earthwork. So here in this valley right here, let me just click on this thin surface and open the properties. You will see you will have some properties as in number of points, number of triangles. You can set on the contours, for example, as well, if you would like to. Okay, this is maybe a little bit much, so you can check the interval as well. So maybe 30 for the big ones and 5 meters for the smaller ones. So that looks a little bit better now. And let's start to create a dam right here in this valley. For that, I'm just going to use the line command. So I just type in L for line, enter, and just snap from one side to the other, for example, here. The placing for now, it doesn't really matter because afterwards you can still replace it or move it around if you would like to. For this dam, I'm going to use the grading and select this line and use the offset option to create a flat surface, maybe 5 meters of distance and then 0 degrees. So I will have a flat surface onto that. So you will see now I kind of have a road connecting. Let me also do this for the other side of the road. So same grading from this line with the option offset and then distance of 5 and 0 degrees, like this. So now I have this flat part right here, but I also want to have it connected with the surface itself. So like this, I can create a slope surface with a degree of 75. Same for the other side. Like this, I will have a little dam created. These are all connected to each other. So if I select my line here again, and for example, move it to another space or something like that, you will see it will move along. Let me just move this a little bit and we move, for example, here. You will see that it will update instantly and change the grading here, touching the existing tin surface. It also works with, for example, if you manipulate it and maybe move it a little bit more to this side, you will see it will move along as well. So you can still edit it afterwards. Okay, so let's say this is the way I wanted them to be. I can merge these separate little gratings to one bigger surface. So then I can calculate the tin volume surface out of this. So let me just merge these layers like this and delete the merged layers like this. And like, voila, so I have this one tin surface instead of the smaller 4 gratings. So like this, I can calculate the volume that I need to create this dam. So for this, I'm going to use tin volume surface and select the comparison surface, so the existing boundary area. Okay, so now if I zoom out, maybe I should do it the other way around. Let me just do that quickly. All right, that's better. So here at the 0 level of the z-axis, I will have this projected onto. So if I select this tin volume surface, you will see this. You can check the properties and it will state the cut and fill volume, for example. So for this dam to be created, I will, for example, need 90,000 cubic meters of volume. So like this, I can check some fill and cut and other properties for this dam right here. Another thing that we can do with this dam is extract this from tin. So extract from tin, I'll select the tin surface and I can extract several things. I can select, extract a mesh, a solid, maybe just the points, maybe just the faces, maybe just the border, anything like that. But in this case, let's extract a mesh and then choose between surfaces. So I'm just going to select the comparison surface right here. And like that, you will see now on top of my dam, I will also have a mesh. Let me just move it down so you can see a little bit better. So this is just a visual representation of the dam that we just created like this. All right. For the next part, let me just start to manipulate the existing tin surface. So this one, let me open up my hidden layers right here so you can see better. Again, here a little bit like the image, I have a polyline that's on the 0 level and I want to project it onto the tin surface. So that's projected to tin, select the tin surface, select the polyline, enter. And like this, you will see this polyline projected onto the tin surface. This works also with drawings or anything like that that you want to put on your tin. You can project it onto. All right, so here we have this little boundary right here. So in this space, I want to edit some parts of my tin surface. You can do this with modify tin surface. In this case, I want to deform it a little bit and add in a contour. So I want to fill it up basically with a little bit more earthworks like this on the existing tin. You can also choose for a new surface. But let's do this on the existing. So you see now it's more flat than before. But of course, these modifications, we want to have some numbers on it. So let me just quickly create again the original thin surface inside this clip boundary. So I'm just selecting this little polyline here that we projected, and again import my text files for my original thin surface and click OK. So it will load a little while, but I will only create a thin surface inside of the polyline right here. Okay. So you see this original line thin surface here, and then the one with the image is the modified one. So like this, we can use the both of the surfaces to create a difference, so we can check the fill and cut volume that we need. Again, using thin volume surface, select the white part, so the white thin surface, and then the comparison, so the one with the image, and I'll select the boundary areas. And if I zoom out now, you will see I have this thin volume surface. Check the properties, and you will see I have a cut volume of 302 cubic meters and a fill volume of around 50,000 cubic meters. I can also set a contour for this, so you will see a little bit better the difference. Because what I also wanted to show you is, if I, let me just hide this for a moment. So if I would like to further add modifications to this part, so for example, instead of adding this contour, I can smoothen out some parts of this parcel. So here you will see I can click on it, and here I actually smoothen out some maybe rougher parts of this area. So I have a less steep difference. So I'm just choosing some parts here to smoothen out. So you see also the changes in the contour lines, right? So like this, it's a little bit higher than before. And now if I zoom out again and check my tin right here, if I now escape to exit the smoothen command, you will see also that my volume surface changes, because my comparison surface also changed because I smoothed some parts out. So the fill and cut would be different, of course. So it will be instantly updated here as well. So if I click on this thin volume surface, you will see instead of the numbers from before, it's updated to the new fill and cut numbers. So like that, you will be always up to date to your volumes of your modifications. All right, so that was a little bit again for the thin volume surface. And lastly, what I wanted to show you for the earthworks with tin is gratings. So gratings, instead of editing thin surfaces, you can also create gratings, as in not for a slope or a dam. You can also create it, for example, as in building paths or anything like platforms and anything like that. So here I'm just selecting the closed polyline and just give it a degree slope. And like this, you have your gratings. Again, a little bit like the dam from before, if you select this polyline and you move it around a little bit, you will see that the grading will move too. So if I just move it back a little bit, or maybe move it up, you will see that the grading will also update accordingly. Same for the grip points. If I just select this polyline and let's say move this grip point, so the footprint of my platform changes, you will see that for my grading, it changes too. So that's pretty handy for that. Also for the grading properties, let's check that. You will see that, let's see, also you have a fill and a cut volume. In this case, I don't have any cut, only fill. So my net volume is basically my fill volume. In a lot of cases in civil, you would like to have your net volume as close as 0 as possible, meaning that the fill and the cut should be almost the same in order to be cost efficient. So for that, we also have a new command called balance grading volumes. So if I use that and choose this grading right here and just enter a tolerance for that. So in this case, I'm just saying 5% tolerance for my balance gradings. You will see now it's replaced the elevation of my grading because it was searching for a number that is as close to the net volume 0 as possible in order to have these fill and cut as close as possible to be cost efficient basically. So in that case, my grading should be somewhere like this in order to have a net volume close to 0. So like this, I can select my grading and lastly add a boundary. So I can delete this part that's overlapping with the thin surface like this. And then you can place your buildings or something like that onto it and further create